Hello, everyone. We are going to look at lesson 2.2 today. It's on the distributive property. This is something that I'm sure you all have seen before, and it's usually about half and half. Either you understood it and you can do it pretty well, or it didn't make sense and you struggle with it. So what the distributive property is a way that sometimes it makes a problem easier. Sometimes it helps you simplify a problem, but it gives you what's called an equivalent expression, meaning they're the same thing. So the distributive property, what it's saying is, if you have something times a group, and there's some sort of operations going on in the group, addition or subtraction, you can either, if generally with the order operations, you would add the inside and then multiply. But it's also saying you can multiply the outside number by each of the inside and then add them. Okay. So especially with variables, we can't add B and C together. We don't know what they are, but we can, and then if we could, then we can multiply by A, but we can't. So then we will take A times B, which is AB, and then put the plus and then A times C, and we get AC. It doesn't matter where the outside multiplication is, if it's before or after the parentheses. Here you'd go A times B and then A times C, and it doesn't, the order that you write those doesn't matter. You could still write AB plus AC because it's multiplication. It works with subtraction also. So if you're here, you have that and that, okay, or A times B minus A times C, okay? So with numbers, now this looks like, why would you do this? And I agree, you wouldn't, they're just showing you the rule. You wouldn't actually do the distributive property to do these, most likely, because you could just go 6 plus 3 is 9, then times 4 is 36. But they're just showing you that also, if you take 4 times 6 and then plus 4 times 12, this gives you 24. This gives you, or sorry, 4 times 3, which is 12. If we add them, we still get 36. So no matter, the order operations would say you'd add them first, then multiply. But you could also use the distributive property. Okay, it works with subtraction too. Usually here you'd go 7 minus 2, which is 5, and then times 5 is 25, but we could go 5 times 7, and then minus 5 times 2, and same thing here, 5 times 7, minus 5 times 2, so we get 35, minus 10, and we still get 25. Okay, so they'll show you a word problem here. We'll look at it, but I don't really think you would use distributive property here unless it was for mental math purposes. If you didn't have a calculator, and I'll show you that. But for your test, you're probably not going to have to do that. It says you are buying beads from for a craft project. You need gold, silver, and white. A bag of each beads costs $3.99. Use the distributive property and mental math to find the total cost of beads. So if you were just estimating, you'd say, okay, you got, you're buying 3 bags of gold, silver, and white, and they're $4 a piece, estimating. So estimating, you'd say $12. But if you want an exact price, what they're saying is you could write the $3.99 as 4 minus 1 cent. Okay, and then use the distributive property. 3 times 4 is 12 right here, and then 3 times a penny is 3 cents. So they get the $12 minus the 3 cents is $11.97. Okay, if you follow along with that, great. If you didn't, it's not a huge thing. But it might just, things like that are useful in real life. That's probably not going to be on the test unless they said like which one of these would make sense for this problem. You're not going to have to write this out from scratch. We'll just look at these ones. Again, I wouldn't expect you really to do this in real life because you would just go 9 plus 4 is 3 times 2 is 26. But they're just saying if you did that, 2 times 9 is 18 plus 2 times 4 is 8, and that equals that 26. Same thing here. You could go 12 minus 3 is 9, times 3 is 27, but they're just showing that you can go 3 times 12 is 36, minus 3 times 3 is 9, and you also get the 27. Make sure you keep track with negative numbers here. You do this, you get negative 16 when you take negative 4. Now here's a tricky part. There's 2 ways you could do this. You could just know that you're taking negative 4 times a negative 11, or times a minus 11, and it'd be plus 44. Otherwise, you would say I got a minus, and then negative 4 times 11 is negative 44. You'd either use your calculator or know that minus a negative is the same as plus positive, and then you get the 28. Okay. I'm not gonna, again, these probably won't be test questions here, but what they're trying to get at here is if you're doing this mental math, instead of thinking what's 5 times 103, you could break it apart and say, okay, 5 times 100 is 500, plus 5 times 3 is 15, so that equals 515. Same type of thing here. It would be kind of hard in your head to go 4 times 3.8, but some people could do this. Okay, 4 minus 0.2 is the same as 3.8. So 4 times 4 is 16, minus 4 times 0.2 is 0.8. And you subtract those, you get 15.2. Okay. And then number 6 would be very similar. So let's move on. I don't think we need to do another example of that. Where the distributive property comes in big is when we start looking at algebra and solving things and simplifying expressions when we don't have a number yet for the variable. So right here, to simplify, we can't do x plus 10 because we don't know what x is. But to simplify this, we go 2 times x, which is just 2x. Okay. Then we go 2 times 10, which is 20. And this is your simplified answer. Okay. 2x plus 20, that's all we can do. We can't say that's 22x or anything like that. Okay. Same thing here. We got, well, negative 4 times m is negative 4m. And then negative 4 times 3 gives you negative 12. So this would be a correct answer here. Negative 4m plus a negative 12. Now in algebra, they're going to change that a lot of times to this form. Instead of saying negative 4m plus a negative 12, they're going to say negative 4m minus 12. It's the same thing. I will count either one correct. Okay. This is where we're going to run into some issues sometimes. I'll show you a couple different ways of doing this one. But we go negative 3 times 2i gives you that negative 6y. A lot of people will get that right. Okay. Then here, if they say minus sign, they put the minus sign here. And then they go negative 3 times 6 is negative 18. That changes to plus a positive. So negative 6y plus 18 is your answer. One thing some people just know that, okay, if I'm doing this problem, okay, so we take the negative 3 times 2y, that's negative 6y. And now they just look at this and know that, okay, I'm taking a negative 3 times a minus 6. Negative times negative gives me a plus 18. Okay, so that might take getting a little used to. You might have some questions on that. If you do, let me know. That can be a little tricky at times, keeping those plus and minus signs right. Okay, let's take a look over here. Kind of goes backwards here, but you still 4 times x is 4x. 4 times 7 is 28, and there's a plus in between. Here's where we get those negatives going here. So negative 3 times 4m is negative 12m. Okay, then negative 3 times a minus 7. That's just the way I look at it and say, okay, negative and negative changes to a plus. Okay, so it's a plus 21. Okay, another way that some people do that is you pick the way that's best for you. Even before they multiply, they say, okay, it's a minus 7, but that's the same as plus a negative 7. So now they get the negative 12m, and then negative 3 times negative 7 is a positive 21. Okay. And also, as I'm going through any of these, if I'm going too fast, hit pause or rewind and listen to it again, or pause and just think about it for a minute. Okay, the last type of problem we're going to look at here, find an area of some of these figures. So area of a rectangle, remember, is length times width. Okay, and so the length is 3x plus 2. Width is 5. So you just use your distributor property. 5 times 3x is a 15x. 5 times 2 is 10 with a plus in between. So this is your answer. We don't know what x is yet, so that's our answer. And then later on, if they say, well, x is 2, you just put that in there. This one's a little more tricky. Just make sure there's one extra thing here. Area of a triangle equals area equals 1/2 base times height. Okay, so this 1/2 is part of the formula. We have the base is 14, the height is 12 minus 3y. So one thing you might want to do first here is you write all those out. Now again, what we just did in 2.1 is you can do these in any order. We could go 14 times this first and then times 1/2, but what the easiest is go 1/2 times 14. Okay, if you needed to in the calculator, remember 1/2 is 0.5 times 14 equals 7. So that's where they get the 7. And now you go 7 times a 12 is 84. And then 7 times a minus 3y is minus 21y. And there's our answer. Okay. So let's try this again. If we go length times width, you could go 5x plus 3, then times 7. I like doing the single number first. Remember, it's multiplication, so it doesn't. I can write it like this and do width times length. Doesn't matter. Then you go 7 times a 5x. It's 35x. 7 times a plus 3 is plus 21. There's your answer. Okay. All right. Formula here, remember, it's 1/2 base times height. So the base is 10. 1/2 is just part of the formula. 9 minus 2y is the height. So the first thing we do is we're going to take 1/2 times 10, which is 5. And then we have the 9 minus 2y here. So we go 5 times 9 is 45. And then bring down the minus. 5 times 2y is 10y. Okay. And there is your answer. All right, so that's the problems in the note-taking guide. Did go that a little fast. Watch it back. Okay, go back and watch it again. Okay, study guide. You go through. They show some examples here. You know, I'm not too worried about these type of problems, the mental math ones. These would be pretty important. Okay, being able to do those. So do those 4 problems. If you got that, you should feel pretty good. And then also doing these 2 should be important too, 10 and 11. So if you can do 6 through 11, okay, you're pretty good on 2.2. So that would be my main focus there. Again, if you want extra credit or just more practice, again, I wouldn't worry too much about this. I wouldn't worry too much about that. These would be pretty important. And then any of these word problems. Okay, 20 might be a little tough, but it's a good problem. Basically, what you're doing is just what we just did. The last 2 problems we just did, doing them together, and then add it all together. So you do this box would be one problem like we just did. This would be like the triangle we just did, and then we put them together. So I wouldn't say necessarily this is a test question too much, but the parts of it would be. Okay. And then down here, these would be definite ones that could be test types of questions. So if you're going to do some practice, this would be, you know, I wouldn't worry about these, the 1 through 12. It'd be kind of 13 through 23 for the extra credit. So study guide, 6 through 11. If you got those, you're going to be doing pretty well. Okay. And then practice extra credit if you want to even get more solid on it. So again, after this, watching this video, make sure you send me a personal chat message saying I watched video 2.2. If you have any questions, let me know.